do? We take a packet, any packet which is traveling from your data center to your branch. We take that packet and we route that packet from your router to our devices. And that particular device is known as VAS. And what does VAS do? VAS just optimizes, compresses that particular packet and then sends it over to the WAN link. So what happens? For an example, if you see how does TCP work? TCP basically works on a 64-byte packet fundamentals. So what does it do? When a 64-byte packet travels over the WAN, basically uncompressed, so basically it takes more bandwidth, or maybe if the round trip time or the latency is high, it is prone to more getting congested. So now when we deploy VAS, what does that 64-byte packet becomes? Basically it gets compressed to a level of somewhere around 100%. So this means somewhere around 6 KB. Now when a 64-byte packet can be compressed up to a level of 6 KB, then the condition is this, and that packet over a minimum bandwidth can travel faster than a 64-byte packet. And how do we do that? So if you look at this is the normal OSI layer that we have. So this is a stack, basically. Now, when a host A is sending any packet to host B, it starts from the application layer and goes up to the physical. Now, if you look at it, we have certain VAS devices in between. So what are these VAS devices doing? Basically, over the session layer and presentation and application layer, where exactly the data packet resides, we compress that particular part. We don't touch the physical layer, we don't touch the data link, we don't touch the network. The only thing that we're doing is we're touching the body where exactly the packets are residing. So we compress that and we send it over the WAN. The other side WAN device, the WA device, basically decompresses it when it receives over the WAN and then delivers it to the local host. So if you look at it, there is a clear transparency of the packet from the LAN and it only gets compressed or optimized over the WAN link. So what is it? The beauty of this solution is that if you deploy VAS devices in your network, they automatically configure each other, or maybe they discover each other. So you don't need to have any manual intervention where you need to go and define certain IP addresses, or maybe define any policies, or maybe define any tunnels just to discover those devices. It's all automatic. So you deploy two devices, they'll discover each other automatically. So this is how, if you look at it, this is the discovery that is happening between them. As soon as you deploy two devices, there is a sync and async packet which travels to each other. They discover each other, acknowledges, and then they say, okay, I'm alive, and exploration is confirmed. So another benefits are data redundancy elimination. So many times you would have faced a problem wherein, on your branch side, if there are, let's take an example, there are 10 users. If one user downloads a particular file from a data center server, another user tries to download the same file. What happens? That files travel twice on the WAN link. This means the same file which is being downloaded by two different users travels twice on the WAN link, consuming your bandwidth. And if you look at it, bandwidth is really expensive as of today. So data redundancy elimination is a feature in VAS devices where if the file is being downloaded by any of the users in your branch office, if the second user tries to download the same file, it is delivered from the local WA device, which means that it is saving your bandwidth. Now for an example, if the file is changed on the data center side and the second user tries to download the same file, at that moment only the changes are sent, not the original file. So this is how, again, data redundancy elimination helps you to save your expensive bandwidth. This is another example. So many of you would be familiar with this particular graph. What is this graph? This is a network bandwidth utilization graph. And can somebody tell me why every time when you see the network bandwidth diagram, it is always in spikes? Why it is not constant? The reason is, as soon as you touch the 60% of your bandwidth lane, for example, if you have been given somewhere around 256 kbps of bandwidth, so as soon as you touch the 60% utilization of that particular bandwidth, your bandwidth is dropped to the 30% level. And why is that so? Because TCP has been designed to work in that particular manner only. So this is where, if you look at it, the inability to use available bandwidth. That is where you are still investing your money, but you are not able to utilize the bandwidth. Okay, because this is another feature wherein we provide security over WA devices, which is the encryption option. So what happens on a WA device? For an example, you have a WA device and somebody steals the hard drive of it. So what would happen? You can lose your data, but not. This is where WAE keeps every data encrypted over it, on it. So basically what would happen? Any data which is exchanged between the branch and the data center is encrypted. Now nobody can read that, and if somebody steals the hard drive also, you will not be able to open any of the data out there. Now I'm going to talk about something about specific application exploration. So you would have seen there are certain applications which exchange a lot of data and a lot of packets which are not required. For an example, a user says, okay, open this particular website or get me this particular JPEG file. In a normal scenario, what happens? JPEG file is sent, right? This is a normal scenario. If the second user tries to download the same file, then what happens? With Cisco VAS, that is delivered locally because that has already been cached into the system. So there you save a lot of bandwidth over the WAN. Second example I'm going to talk about is what happens in case a user is trying to browse any website and that particular website address has been changed or maybe it has been reconfirmed. So what happens if the second user tries to download the same or tries to open the same website? It is again from the branch office WA devices. The option is given, okay, that this website has moved. The new URL is this one. So again, the same packet which would have traveled over the WAN, consuming a bandwidth, is done from the local device itself. Now this is a very good example. Many people have been talking about video. Video is the future. And if you would have looked in today's world, what happens in a normal organization? You have a media server where you store your media contents. That media content is browsed or opened by your branch users, or maybe a live demo. So what happens? A person says, okay, this is a published URL or maybe a published media file that I would like to open. He opens the media player. The media server gives a unicast string to it. Now what happens in case from a branch office, 3 or 4 users are trying to open the same media file? Then that particular media file has multicast sessions or maybe unicast sessions with different users. Now what does it do? It creates a bottleneck. Bottleneck on the bandwidth, bottleneck on the server. Now with VAS, what happens? With VAS, if you look at the difference is very clear. That only one stream is being sent over the branches.